compression and data preservation. SRI International. The Dish SRI International. Following. Published in The Dish. 3 Minutes Read. July 26, 2023. Listen. Share. More. Whether it's for mapping a landscape, visualizing the detailed anatomy of a patient, or analyzing the structures around a self-driving car, three-dimensional imaging has become an increasingly powerful tool. Thanks to advancements in 3D sensors and imaging techniques, researchers are able to collect more detailed 3D data than ever before. But to be of use, this huge amount of data must be processed, stored, and shared. Researchers at SRI's Center for Vision Technologies, CVT, have been developing and improving techniques to compress 3D data effectively, reducing the size of data files while still preserving the most important information. You want to go from an exact point with the original geometry to something with slightly more error, so it can occupy less space, said Bogdan Matei, a technical manager for CVT. But you want that change to be generally imperceptible, like a photographer going from a high-quality RAW file to a compressed JPEG. Matei and his colleagues are focusing on data obtained from LiDAR, a 3D scanning technique that involves rapidly bouncing a laser off of distant objects to create 3D maps made up of millions of individual points. To compress this data, they are finding ways to group points together. In a landscape, some objects can be represented by fewer points than others. Man-made structures, for example, tend to have smooth sides and uniform construction. One of the compression methods the researchers have developed takes advantage of this by linking all the data about, say, the flat top of a building as if it were one big pixel in an image. A key aspect is that we use the semantics of the scene. What is the ground? What is a building? What is a car? We assume all that is known, Matei said. Because buildings and ground have more redundancy in the data, they can be compressed more than, let's say, a tree. And because they are working with overhead mapping data, much of the vertical information is empty space, Matei said. The researchers are able to store a lot of the data in 2 dimensions instead of 3, making it even smaller. Using this method, the researchers found that they could compress LiDAR data 3 to 7 times more than the standard method of compression, known as LAS, although their method does lose more data. The second method that the researchers are working on can compress data as much as 30 times more than LAS, with acceptable levels of data loss. It relies on the assistance of neural networks, which use an interconnected series of algorithms to process and analyze data. In this case, the researchers have trained the network to recognize and compress point data. Rather than having an explicit list of points on a surface, you find its equation, Matei said. But it's not a simple equation, it's a complicated function that is learned with a deep neural network. That function takes up less space than storing each individual point. Moreover, the researchers found that they could train a generalized network ahead of time and then adjust its parameters for specific data sets, making it even more effective. The big network is like a universal dictionary of shapes. Then you can adapt it for a particular dataset and compress things differently based on their class, Matei said. For example, with vegetation, you don't need much precision for some applications. So you can compress it a lot. The researchers are hoping they can improve on both methods of compression, making it easier to collect and store data for aerial mapping, training self-driving cars, or other forms of artificial intelligence. It can become very complicated because these points can have color or other attributes as well, Matei said. We want to refine what we've done and improve the compression even further. 3. Image Processing 3D Modeling Imaging Computer Vision Innovation 3. SRI International The Dish Following. Written by SRI International 293 followers. Editor for The Dish. We create and deliver world-changing solutions for a safer, healthier, and more sustainable future. More from SRI International and The Dish. 75 years of innovation. The Computer Mouse. SRI International. SRI International. In The Dish. 75 years of innovation. The computer mouse. A major development in human-computer interaction, HCI, driving the advent of more accessible and controllable consumer computers. May 7, 2020. 15. Tech history. The story behind Stanford's satellite dish hiking trail in Palo Alto. Rini de Malhotra Hora. Rini de Malhotra Hora. In The Dish. Tech history. The story behind Stanford's satellite dish hiking trail in Palo Alto. The scoop on the past and present of the famous radio telescope that is still active today. September 9, 2019. 42. Featured innovator. Indira Jayawira. Sri International. Sri International. In The Dish. Featured innovator. Indira Jayawira, a senior program manager whose curiosity captures carbon. January 12, 2022. 2. Want to know if it's nature or nurture? Look at twins. Sri International. Sri International. In The Dish. Want to know if it's nature or nurture? Look at twins. Sri and Stanford are among the leading global research organizations that have studied twins to better understand the genetic and June 23, 2020. 9. See all from Sri International. See all from The Dish. Recommended from Medium. Detect and extract table data using OpenCV. Rajashekhar Ganigar. Rajashekhar Ganigar. Detect and extract table data using OpenCV. This example demonstrates how to use OpenCV for table data detection and extraction. We'll be analyzing some example outputs generated by May 25. 2. The power of synthetic image datasets. How Blender is revolutionizing AI training. Merwansky. Merwansky. The power of synthetic image datasets. How Blender is revolutionizing AI training. Synthetic datasets with Blender. Part 4b. 5D ago. 5. Lists. A man with tattoo, beard and glasses, smiling at many mini robots around him. AI image created on Midjourney by Henrique Sentiero and B. Lee. Screenshot showing verified email sender badges in Apple Mail and Gmail for the sender, Jano LaRue, highlighting email authentication with checkmarks for a trusted communication. Tech and Tools. 19 stories. 303 saves. AI opportunities are found at the intersection of problem space and information space. Problems that involved cognitive tasks are worth solving with AI. Problems for which sufficient data is available are feasible to be solved with AI. Business. 41 stories. 140 saves. Data science and AI. 40 stories. 241 saves. Generative AI recommended reading. 52 stories. 1360 saves. Custom alpha-shaped class to extract planar point cloud data. Boundary point open 3D C++ code, planar. Point cloud slam image web 3. Point cloud slam image web 3. In Point cloud Python MATLAB C++ lib. Custom alpha-shaped class to extract planar point cloud data. Boundary point open 3D C++ code, planar. A custom alpha-shaped class was used to extract the boundary points of the point cloud data and visualize it using the Open3D library.